Hello and welcome to part 2 of Team 2168's Intro to Java lessons. The link to the playlist of these videos will be in the description so you can easily find the other lessons. If you didn't do the Lesson 1 review and lab, I recommend watching that video. But for now, let's get into this lesson. First up is a short review of the last class. So computers only understand zeros and ones. Humans use programming languages to avoid writing machine language, that being high-level languages. Compilers translate high-level languages into machine code. This is called compiling. And Java is the language that we use on our team for our robot code. Java compiles to bytecode first, and then uses an interpreter on the computer to convert bytecode to zeros and ones. The interpreter works by converting a single line to bytecode, executing it, then moving to the next line of bytecode. The interpreter is called the JVM, the Java Virtual Machine, and your bytecode can run on any computer as long as a Java Virtual Machine is installed. We wrote our first Java program. We defined what a class header, class body, method header, method body, and main method are. We also learned that every Java program contains at least one class and a main method. We learned that we could print statements using system.out.println. We learned that every Java statement ends with a semicolon, much like how English sentences end with periods. We learned that Java is case-sensitive and that it has built-in math operations: addition, subtraction, multiplication, and division. We saw that Java allows us to create variables, but you must declare the type of data you want to use it for. Ints allow you to store integers, doubles allow you to store decimal numbers, floats allow you to store around half of the digits that doubles store, and they also are for decimals. Strings allow you to store a string of characters, but they must be placed in quotation marks. And chars allow you to store a single character, but must be placed in single quotes. Using the word final before any variable allows us to make it a constant, meaning the value cannot be changed after it is initialized. There are rules for naming variables, so most of the time we use camel case, but for constants we write the names in all uppercase with words separated by underscores. Using the assignment operator, we can assign values to variables and then use those later on in our program. And using the plus operator, we can concatenate strings, as well as use them for addition. You wrote real computer programs, and you realized that Java is a language. Just like English or French, it has rules for sentence structure, but otherwise can be learned with a little practice. Now, before we get into language syntax, I first want to go through how to solve errors in your code, since it's likely that you faced some of them during the last lesson and didn't really know how to deal with them, since I can't really help you with this being a video series and all. So I want to show you how you can kind of solve problems in the code and figure out what might be wrong. A lot of the time with your code right now, the error is going to be something simple like you forgot a semicolon, or you capitalized something when you shouldn't have, or made it lowercase when it should have been capital. So they shouldn't be too difficult to figure out, but I'm just going to give an example of an error. So in this case, I just deleted the semicolon, which is going to result in an error because every statement needs to end in a semicolon. Now here you can see that there is a tiny red squiggly line. So that's the IntelliSense. It's just telling me what my errors are without me having to run the code. So if I hover over this, it'll say that there's a syntax error, insert semicolon to complete statement. So that's very nice. It tells me immediately what I need to do to fix the problem. But let's say you just don't see that red squiggly line because you have a really long file, and you run the program with this error. So VS Code will give you a pop-up that says build failed, do you want to continue? And then it'll show you the problems section down here, which will tell you what the errors in your code are. So here it'll say the same thing, syntax error, insert semicolon to complete statement. But it also has this little list of 2 numbers here. So this is really nice because it tells you what line the error is on. So that 5 is telling me that the problem is on line 5. And indeed it is. That second number, I believe, is the number of the character in the line where the problem starts. So it would be the 30th character. Now, this is not always correct with what line it tells you. Sometimes it will be wrong. So if it ever is telling you what line a problem's at, and you look at the line and you just can't see anything wrong with it, it could just be that it's incorrect and it's telling you the wrong place to look. But most of the time it is going to be correct. So this is really useful to know. Now, for a lot of IDEs, it won't give you this useful problem list, and instead it'll just go on to compile the code, and then it'll give you the error in the terminal. So I clicked proceed there to compile it anyway. And this is what an error looks like when it's printed to the terminal. So it's very similar, but it has a couple differences. Here it says exception in thread main. So that means it's a problem in the main method here. Java.lang.error unresolved compilation problem. So that's just saying that there's an error in the code. Syntax error, insert semicolon to complete statement. Again, same thing as before. It's telling you how to fix the problem and what the problem is specifically. And then it says at my first program. So that's saying it's in the file, my first program. .main, it's in the main method. And then my first program .java:5. So that again is telling you that it's on line 5. So with this compiler error, it gives you even more information, like what file it is, and I believe the problem section gives you that information too. But if you're ever in an IDE that doesn't have this, the compiler error will tell you what file the problem is in and what line it is at, which is very useful information. And it'll also tell you what method it's in. And we'll learn about methods later, but for now, it's just going to be the main method. Now I'll give another example of a possible error. Let's say you have this variable that's an int, and then you try to assign it to a string. So if you put quotation marks around this number, it's going to throw an error because putting quotation marks around it means it's a string. And this is an int that you're trying to define. So here it'll say type mismatch cannot convert from string to int. So it's saying you're trying to set this variable, which is an int, to a string value, but I can't convert this string to an int. So that's how you know, oh, the type here is wrong. Let me change it back to an int. If I look in problems, it'll say the same thing, but it tells me it's on line 19, as it indeed is. And then if I run this, and then click proceed to compile it, it'll say exception in thread main, java.lang.error, unresolved compilation problem, type mismatch, cannot convert from string to int. And then again, it tells me what file it's in, as well as what line it's at. So definitely when you have errors, try to read these messages instead of freaking out. It'll tell you what the problem is and what line the problem is at, and then these red squiggly lines will tell you exactly where the problem is. Sometimes it is wrong, and sometimes error messages can be confusing. So if you're ever unsure about something, don't be afraid to just Google the error message. Honestly, like a large portion of programming is just looking things up on the internet, so don't be afraid to use search engines to find information. With more complex programs, you also might run into problems where it'll give you multiple errors for the same problem. So, for instance, if you have an error in the code, but you are using that part of the code in another file, so one file is referencing code that's broken, it'll give you two different error messages for both of those areas of the code, and you might have to go through the different errors and figure out what the real source of the problem is, since it'll tell you multiple places, since there might be multiple places where you use, say, a variable that's broken. I get that kind of problem a lot with robot code, with the driver station logs and the real logs. It will give a lot of different errors with different line numbers because a lot of the code uses other files within the code. So I have to go and find which file the problem originates from. Now we can close this and get into syntax. So syntax is the arrangement of words and punctuation that are legal in a language. Essentially, it's the grammar rules of a language. So the term grammar and the term syntax are very, very similar words. With natural languages, we tend to use the word grammar more often, but with programming languages, we use the term syntax. So we've learned a few syntax rules of Java so far. For example, Java is case sensitive. You must write public static void main string args to start a program. Every program must contain a class definition, and every statement must end with a semicolon. Just like how in English, every sentence has to end with a period, and in many other languages as well. If you do not follow the rules of the Java syntax, your program will not run because the compiler will be unable to convert it to zeros and ones. So it's a lot like how if you write in very broken English, the person who's reading it won't be able to translate it in their mind because they don't understand. Language keywords. Certain words in Java have special meanings and alter how the program is executed. These words are called keywords or reserved words. So examples of keywords are public, final, class, int, double, and static. They can be called reserved because, as we've mentioned before, these words can't be used as variable names, so in a way they're reserved for other uses. When these words are written, Java recognizes them as special terms used to control the program. We'll learn more keywords as we learn the language. You cannot use a keyword as the name of any variable, class, or method. Java will get confused. So if you try to make a double called final, it won't work. This is illegal because final is a keyword and can't be used as a variable name. And you can see final is highlighted in the same color as double because both of them are considered keywords. So Java will think that there is no name for this variable. So more about syntax errors. One of the reasons we use VS Code is because it will tell us if we've made syntax errors. And that's pretty much what I showed you at the beginning of this lesson. So here it's missing a semicolon, and in the terminal it will tell you. Here's an example where the S isn't uppercase, so it says system cannot be resolved. So in this case, it doesn't know what system is because you used a lowercase s instead of an uppercase s. Then here are some examples with missing brackets. It'll say insert bracket to complete class body. There's also a second error in this picture. It might be hard to see because it's small, but there's a constant, and then it's trying to assign another value to the constant. So this is also an error since constants can't change values, but only one error is shown at a time. Errors are natural. As a programmer, you will get errors. The key isn't to avoid them, but to be sure to recognize them. Sometimes error messages are a bit cryptic, but with experience you'll be able to determine what they mean. In cases where you have multiple errors, the compiler will only show one, and you must continue to fix each error until the compiler is happy. Branching with Java. So we learned a bit about branching last time, but we're going to go a little bit more in depth. We may wish to write a program that makes decisions and executes different code depending on the situation. So here is an example, and we're going to go write this in VS Code. Alright, we're going to make a new program called Salary Calculator. So up here, we'll click New File, and remember to capitalize each word, Salary Calculator, and add .java, and here we go. So first we have to make the main method, as always, public static void main string args. Then we'll add an integer called hours worked. And this is going to be 40. It's necessary to know how many hours someone has worked if you're going to calculate their salary. So then we'll add the pay. And remember that we don't need to initialize in the same line as we declare the variable. So declare int and initialize. Declare double uninitialize. Then we want a constant called pay per hour. So we'll do a final double, and remember that constants are in all uppercase, pay per hour. We'll say it's 18. And we'll specify that it's in dollars per hour. So then we'll do an if statement. If hours worked is greater than 40, pay is pay per hour times 40 plus 1.5 times pay per hour times hours worked minus 40. This code will be explained in the break it down slides, but this is for if they worked overtime, so they get extra pay for working overtime. Then we can say else pay equals pay per hour times hours worked. So all of that is calculating the pay. So then we'll say, we'll print this all out. Hours worked this week. Hours worked. And then we'll say your pay per hour is, and then concatenate pay per hour. And finally, this week's paycheck is, and then concatenate that with pay. All right. Let's break this down. We start our program and declare hours worked as an int and set it to a value of 40 hours. We also declare the variable pay as a double, but we don't set it a value yet. So right now we don't know what the pay is because we haven't calculated it yet. That's why we declare it uninitialized. So then we create a constant of type double named pay per hour. Then we have this if statement where if hours worked is greater than 40, meaning they worked overtime, the pay is the pay per hour times 40 plus 1.5 times pay per hour times hours worked minus 40. So they get their regular pay for the first 40 hours and then the overtime pay for the rest of the amount of time they worked. Otherwise, pay is pay per hour times hours worked, so they just get their normal pay. So again, if the value of hours worked is greater than 40, Java executes this. Whereas if the value of hours worked is less than or equal to 40, meaning it is not greater than 40, Java will execute this. So that's how the if-else statement works. Else just means if this isn't true, then do this instead. Now, we've seen this before, but if the statement under if or else is made up of more than one statement, they must be enclosed in curly brackets. So this has two statements and this has two statements. Any statements outside of the brackets under the if will be executed whenever the condition of the if statement is true. So let's create a new file called lesson2.java. And of course, add a main method. we will write the code that we saw. So double amount is 27, double balance is 12, then if amount is less than balance, we can say thank you. Withdrawal will take place. So we wrote a similar program before. And then balance will become itself minus amount because you have withdrawn money. But now we know that we can use the else statement. So if this condition ends up being false, instead of doing this, we can do something else instead. So else, we'll print that they have insufficient funds, as well as asking them to enter a lower amount. So not only does this demonstrate how we can use an else statement, but it shows that, again, when we have multiple statements under an if statement or an else, you have to surround them with curly brackets so Java knows they're still part of the if or still part of the else. So let's run this and see what happens. So since 27 is higher than 12, we end up getting this within the else statement printed out. Insufficient funds, please enter a lower amount. So if I change this to 9, pause and think about what will be printed out to the terminal. It now prints thank you, withdrawal will take place, and it does not print any of this. Sometimes we want to do nothing if the condition is false, and last time we just did not have an else statement. So this is some code we wrote last time. But if we don't want it to do anything, if the condition is false, we can just omit the else statement to just have an if statement. So in this case, it won't do anything if x is greater than 10 or equal to 10. It'll just skip this and then move on. Now we'll talk about comparison operators. The condition in an if statement must evaluate to true or false, as we've talked about. Java has many different operators which allow the user to compare items, which will result in a true or false value. So here we have a table with the math notation, the name, then the Java notation, and examples. So in math, the equal sign is the equal to operator, but in Java, we write that as two equal signs. So an example is x plus 7 is equal to 2 times y. That'll either be true or false. It either is equal or they are not equal. Then in math notation, this is not equal to. In Java notation, we write an exclamation point followed by an equal sign. So an example is score does not equal 0. Again, that'll be true or it will be false. Greater than is the same in Java. An example is time is greater than limit. Less than is also the same. Example is pressure is less than max. Greater than or equal to is written as a greater than sign and then an equal to sign. So age is greater than or equal to 21. And less than or equal to, similarly, is a less than sign followed by an equal sign. And an example is time is less than or equal to the limit. So now let's get some practice with these operators. Underneath our if-else statement, we'll write double pressure. Then we'll put final double max pressure. Let's make pressure 23.5 and maximum pressure will be 100. Then we'll have an int called age, which can be 15, and another int called score, which will be 93. Then we'll make some print statements using the comparison operators we learned about. So system.out.println, pressure is less than maximum pressure. Then we'll do age is equal to 0. Age is not equal to 0. And finally, score is greater than or equal to 90. As usual, pause for a second and try to guess what will be printed out to the terminal. As we talked about, these will all become Boolean statements, meaning they evaluate to true or false. So pressure is in fact less than the maximum pressure. 23.5 is less than 100, so it prints out true. Age is not equal to 0, so this statement is false, so false is printed out. Age not being equal to 0 is true, so true is printed. And the score is greater than 90, so this statement is true. Score is greater than or equal to 90, so true is printed out. Now, there is a slight pitfall with using the equal to comparison operator. So although the equals operator correctly tests two values of primitive types, such as numbers, it doesn't always work on strings. So if you made a string called my name, and this notation is strange, but it's possible to be used. So if you wrote it out like this, and then created another string called your name with the same value, and then compared these, the result would be false, even though they are identical. Using the equals operator with strings does not always work because strings are not primitive types, as we talked about in lesson 1. So there's a reason for this. It might not make much sense quite yet, but the equals operator compares it checks to see if the two variables are the same object in memory. So we don't know what objects are yet, but essentially with integers and other primitive types, if you make two integer variables with the same value, they end up pointing to the same object in memory. So even though they're two different variables, they both go to the same place. So that's what the equal to operator is comparing. With strings, they are not primitive types, so even if you make a string that has the same character combination as another, it won't necessarily point to the same place in memory. It's actually just a separate thing entirely, because it's not primitive. So, although these look the same, they aren't the same in memory of the computer. So that's why it doesn't always work. And again, that might not make much sense yet, but hopefully as we learn about objects in future lessons, it will begin to make more sense. So if the equals operator doesn't work with strings, what can we do? Well, we can guarantee string comparison will always work by using the equals method. So we don't know too much about methods yet, other than that the main method exists and has to be in every program. But for now, just know that if you do a string dot equals and then in parentheses put the other string, it will work as an equal to comparison operator. So let's now try this out. Under here, we'll add a new string called S1. And we'll say it's hello. Then we'll make a string S2 called hello with a lowercase h. And then we can make another if statement. So if S1 dot equals, and then parentheses S2. So this is saying if string 1 is equal to string 2, then we'll print they are equal strings. Otherwise, we'll print that they are not equal strings. So remember that Java is case sensitive, so in order for strings to be equal, each character must be of the same case and appear in the same order. If you want to ignore case, there's another method we can use, but for now, let's run this. So try to stop and think what will be printed out from this code. I'm going to run it. So it says they are not equal strings, because here the h is lowercase and here it is uppercase. So they are not the same. If I make this a capital H, then what will it print out? They are equal strings. If I wanted to compare them without paying attention to case, you can use dot equals ignore case. So that will, as it sounds, ignore the case when comparing whether they are equal strings. So if I run this, even though this is now lowercase, it'll still say they are equal strings because we are ignoring the case. So we'll talk a little more about this type of syntax later, but for now you can do the following for any string. String variable 1 dot equals, in parentheses, string variable 2, or string variable 1 dot equals ignore case, in parentheses, string variable 2. The period symbol is very important to note. There needs to be a period between the variable name and the equals method. Each of these statements will return either true or false. Boolean data type. We saw in the previous example that all of the comparison statements evaluated to true or false. Java has an additional data type which stores the results of these types of statements. A Boolean cannot store numbers, text, or anything other than true or false without quotes. So here you can see some examples. Boolean choice is true, is enabled false. You can also set it to expressions that will evaluate to true or false. So Boolean is legal age is if age is greater than or equal to 21. So again, this right here is either true or false. But if you put Boolean is allowed and try to set it to true in quotation marks, it's going to throw an error because if there are quotation marks, it thinks it's a string. So true and false are keywords in Java, which is why you can use them for Booleans. Now, a Boolean is a data type just like an int, double, or a string, and that's pretty much it. Booleans are very simple. It is also worth noting that in other languages, like I believe in Python, Booleans can store 0 and 1 in addition to true and false, because at its base level, binary is true or false, 0 being false, 1 being true, on, off, true, false. So, yeah. In other languages, you can set them to numbers, but only to 0 or 1. Building Boolean expressions. Java has additional operators called logical operators, which allow us to build complex Boolean expressions. So we have the logical not, logical and, logical or. So not is an exclamation point, and is some ampersands, and or is these pipes. Not negates the value. So if the expression evaluates to true, putting an exclamation point in front of it will return false. And similarly, if you put an exclamation point in front of a false statement, the whole thing will return true. With and, all expressions must be true for the whole statement to evaluate to true. And with or, any part of the expression must be true for the whole statement to evaluate to true. So here we have some truth tables. If you've taken a math class which teaches about logic, you have done these before and seen them before. But basically, truth tables give you some different variables with either a true or false value, and then you use the logical operators to come up with whether the entire statement is true or false. So with not, if x is true, then not x is false, and if x is false, then not x is true. Here it is for and or. If x is true and y is true, then x and y is true, because x and y are both true, and x or y are true, because at least one of them is true. If x is true and y is false, x and y is false because not both of them are true, but x or y is still true because at least one of them is true. If x is false and y is true, x and y is false again because not both of them are true, but x or y is still true because at least one of them is true. Then if x is false and y is false, x and y is false, and x or y is finally false because neither of them are true. Now here are some examples. We are going to write this down, but the first statement before the operator is evaluated, then the statement after the operator is evaluated, and finally the results of both statements are compared using the Boolean operator, and the final result is returned. So with this, it would be that X is evaluated, then Y is evaluated, then the whole thing is evaluated, and the final result is returned. So let's go back to lesson 2.java, and under our if-else statement, let's create a double called time, and we'll set it to 5.0. Then we'll say limit is 4.7, then double max is 6.3, and then Boolean with a guardian is true. Then we'll do Boolean made it is, so this is, say, a race. So if time is less than the limit, so you're at the end before the time limit, and limit is less than max, so both of those things have to be true for you to have made it. So this is an AND statement. Again, this right here is the AND operator. Then we'll do if age is less than 21, or with a guardian, and this is an OR statement, we'll print you are allowed in. And then finally, we'll just print system.out.println not true. And this is a not statement. So if we run this, here's what we'll get. You are allowed in, because with a guardian is true. So at least one of them is true. I don't remember what age is. And not true becomes false. Let's add a blank print statement just to separate these a bit more. And we are good. So using parentheses to control which statements are evaluated first is possible. It's similar to the order of operations, PEMDAS, for math operators. So there are parentheses here and parentheses here, although it's not technically needed. But if you had multiple ands and ors in one thing, you could use the parentheses to control which statements are evaluated first. Now we're going to get into flow control. So flow control in Java refers to the ability to control programs through branching or looping. So you control the flow of the program. Now, technically, the proper term is control flow, or control flow control, or controlling the control flow, or controlling the flow of control. I did research into this. Flow control technically refers to controlling the rate at which nodes send and receive data, which, if you're new to programming, means absolutely nothing to you. And control flow, or controlling control flow, refers to controlling the actual flow of the program, what code happens when, and what conditions, under what conditions certain code executes. But the distinction between those terms is kind of confusing, especially since they're the same thing, but the words just flip spots. So you don't really need to worry about it. But technically, flow control is a different thing, and control flow is what we're really talking about here. But, again, you don't need to worry about it. Anyhow, in this case, we are referring to branching, looping, controlling what happens when, and under what conditions it happens. So several branching mechanisms exist. We've seen if statements and if else statements. There's also something called a switch statement. We also have several looping mechanisms in Java. So there are while loops, do while loops, and for loops, which we will discuss in further detail very soon. Most branching and looping expressions are controlled by Boolean expressions. So as we've seen, if statements rely on conditions, which are Boolean expressions that evaluate to true or false, and loops are very similar. Now, we rarely use loops in robotics, but we will cover them as needed. Loops are pretty important for general programming, so it's still really good to know how they work and what they do. So, as mentioned on the previous slide, Java has 3 types of loops: the while loop, the do while loop, and the for loop. The first thing we're going to write is the while loop. So back in lesson2.java, we're going to say int I equals 10, and then we're going to use that variable for our while loop. I'm also going to add another blank print statement. So while I is greater than or equal to 0, so again, that's a Boolean statement. Then curly bracket, we're going to print I is now, and then I, and then we're going to say I is I minus 1, so that's just going to decrease the current value of I by 1. And then outside the loop, we're going to say the loop is finished. All right. So, as a note, it is convention to use I as the name for iteration variables within loops. If multiple counters or iterators are needed, use j, k, etc. So, essentially, I is a variable that's changing with each iteration of the loop. So we use I for iterator. It just makes sense. Some people use x, but for our team, we use I, and I think that just makes more sense. All of the people who I've seen write code have used I, so we use I as our convention. And it is easy to remember. So let's break this while loop down. This tells Java we want to perform the following statements while this condition holds true. So while this condition is true, do this. The condition here is if I is greater than or equal to the value of 0. So the statements inside the brackets will execute once, and then the condition is checked again. If the condition holds true, the statements will execute again, and this will keep happening until the condition evaluates to false. So at first, I starts at 10, because that's what we set it to. 10 is greater than 0, so this is run. And then I is decreased by 1, so it's now 9. 9 is greater than 0, so this runs. And then eventually, I becomes 0, and that's its last iteration. 0 is greater than or equal to 0. So this is run one more time, and then I is set to -1. It comes back. -1 is not greater than or equal to 0, so this condition is no longer true, so the loop stops. So this basically shows that we can modify variables inside loops. And as I said, in this case, each loop cycle we subtract 1 from the value of I. So here's an overview of the syntax. The while statement has the following syntax. While is a reserved word, then in parentheses is the condition. If the condition is true, the statement is executed, then the condition is evaluated again. The statement is executed repeatedly until the condition becomes false. So while Boolean expression statement, or in the case where there are multiple statements, you would use curly brackets. So it's very similar to the if statement. Now, there is a pitfall here. It's possible to create an infinite loop. So, an infinite loop is a loop that never ends, as its name suggests. This causes the program to never end itself, and it appears to hang. So naturally, this is very bad. So if we were to say that if we were to make the condition I is less than or equal to 10, and then we keep subtracting 1 from I is never going to be greater than 10. So this condition is always going to be true. So this loop will never stop running. So I'm now going to demonstrate this, but first I'm going to run it how it is. So if I come up here and run, as you can see, I starts out as 10, and then it decreases until it gets to 0, and then the loop stops. So just like I explained before, it'll go through this until I is less than 0. But if we make this an infinite loop, that's not going to quite be how it happens. So I don't recommend that you actually run this because it might cause your computer to hang. But I'm going to demonstrate what an infinite loop will do. So now if I run it where the condition is I is less than or equal to 10, and I is always less than or equal to 10 as it keeps getting smaller and smaller, you can see that it just keeps going. And it's never going to stop because it's never going to be greater than 10 or equal to 10. So this naturally is very bad, and you don't want your programs to do this. So it's important to be very careful when making while loops or any loops. So to exit this program, I'm just going to do Control-C. And that's how I can terminate it and stop the loop. So that's what happens with an infinite loop. And that is why loops can be dangerous. Now we're going to talk about the do-while loop. So I'm just going to go back and add a comment for the while loop that you should also add just to have it as a sort of note. I'm going to change this back. And then say that while loops continue to execute as long as the condition is true. All right. So now let's talk about do-while loops. This is what it looks like. It's kind of very similar to a while loop, and we're going to talk about that in a bit. So first, we'll write do after declaring variable I. So we actually don't need to declare it, but we'll reassign it to 10. And then we'll write do with a curly bracket. And then same thing as before. We're just going to say I is now, whoops, need the quotation marks. I is now value of I, and then we'll subtract 1 from I every time. And then after this, we do while I is greater than or equal to 0. And then we need a semicolon at the end. So that looks very similar to the while loop, but a little bit more text. So it might be confusing as to why this is a different loop. Well, do-while loops are very similar to while loops. The difference is that do-while loops run the code within the brackets once before evaluating the condition. So while loops always check the condition first before running the code within the statement within the brackets, but do-while loops will run the statements first before checking the condition, and then after that it'll check the condition every time. So the condition can initially evaluate to false, but the statements within the do-while loop will still run once before checking. So syntax, do and while are reserved words. The statement is executed once initially, and then the condition is evaluated. The statement is executed repeatedly then until the condition becomes false. So if we run this, it's going to do the same thing as the while loop. So let's separate them with an empty print statement. And as you can see, it does the same thing. So do-while loops are useful for very specific situations in which you want the code to run once before the condition is checked. We don't use them very much in our code, but they do exist, so it's important to know about them. Okay, so now let's talk about for loops. For loops are also a bit similar, but as you can see, they have something else going on in this condition. So let's go write a for loop. I'm going to do another blank print, and then we can say for I equals 0, and then semicolon, I is less than 5, semicolon, I plus plus. Then curly brackets, system.out.println, I is now, and then I. So let's talk about this. We know that while loops and do-while loops can use booleans as their conditions. You could have a while loop with statements that run until a boolean variable is set to false. We can also use these loops with a counter variable that increases or decreases each iteration, and that's what we've done so far. We used I as an iterator and then decreased it with each iteration of the loop. However, we shouldn't do this because that's what a for loop is for. So while loops and do-while loops should be used with Boolean expressions that are going to turn false. Because if we want to iterate through something or use a loop to do something a certain amount of times, that's the for loop's job. While loops are for repeating code until a condition is false, but for loops allow you to run statements a specific number of times. So they're very similar, but they do serve different purposes. Now let's break this down. This line defines an iterator I with the initial value 0. So technically it's not declaring it because we've already declared it, but you could declare a variable here as well. So if we made a j, we would have to do int j is 0. But since we already have declared I as a variable, we don't need to say int. We just need to say I gets assigned 0. Then this states that the loop will continue until I is no longer less than 5. So the loop will go as long as I is less than 5. And then this right here is saying that I is going to increase each time. So I plus plus is another way of writing I plus equals 1 or I equals I plus 1. So these three statements are all the same, and they just get increasingly longer. So I like to use I plus plus. Most people do. It's a lot cleaner, but it does the same thing as I equals I plus 1. So this is a way of increasing I each time without writing it in these statements of the for loop. So the way we did it with the while loop was by writing it in the curly brackets. But now we get to do it within these parentheses, so it's very, very clean. But on that topic of I++, I minus minus is also the same as I minus equals 1 or I equals I minus 1. So keep these little statements in mind. So each of these statements in the first line are separated by a semicolon because they are different statements. So just like all the other statements we write in Java, they have to end with a semicolon, except this last one doesn't, since it's in parentheses as a condition. So I starts out with a value of 0, as is defined right here. Since 0 is less than 5, the statements within the curly brackets are executed. After one iteration, I is increased by 1, and the loop checks if it is still less than 5. This continues until I is equal to 5 and the statements have run 5 times. So let's go into the code to see if that works. Alright, so if we come up and run this, does it go 5 times? 1, 2, 3, 4, 5, it does. So the for loop indeed runs 5 times. I starts out as 0, then it increases to 1, then it increases to 2, to 3, to 4, and once it's 5, it is no longer less than 5, so it breaks out of the loop. One more thing with for loops. You can also use for loops to access every value within an array. This can be done in two different ways. So let's try this out in lesson2.java. Now, if you remember, arrays are just lists of other variables. So we learned about them in lesson 1. Now, let's see. So let's make another array called groceries. And it'll be, of course, an array of strings. So as a reminder, you surround each list item by curly brackets, and then you separate them by commas. So in this case, we'll have an apple, bread, clementine, and a donut. All right, so let's add a comment. You can use a for loop to iterate through items in a list. Okay, so the first way is just kind of the normal way that we use for loops. So for, and as I was saying before, you can define an integer in here. So we'll do int j is 0, and then we'll go for as long as j is less than or equal to 3. Since that's going to be the maximum index in this list, as there are 4 items and we start from 0, so 0, 1, 2, 3. So we want it to go until it is larger than 3. And we want j to increase each time. So for each iteration, let's just print out the grocery in the list. So as a reminder, we can access items in a list by writing the name of the array and then the index number. So if I wanted apple, I would do index 0. If I wanted bread, I would do index 1. In this case, we'll do j because it's going to increase each time, so we print a new item every iteration of the loop. So it'll start out with j as 0, so we would print the 0 index, which is apple. Then j is going to increase to 1. 1 is still less than or equal to 3, so it'll print the first index, which is bread. Then it'll increase to 2. 2 is less than or equal to 3, so it'll print out the second index, which is clementine. Then it'll increase to 3. 3 is less than or equal to 3, so it'll print out the 3 index, which is donut. And then finally, it'll increase to 4. But 4 is no longer less than or equal to 3, so now it breaks out of the loop, and it's done printing. So let's see if that happens. Yep, so when we run the file, it says apple, bread, clementine, donut. So we iterated through each item in the array and printed each one out, without having to write it out individually each time. So we didn't need to write 4 different print statements, we only needed to write 1. That's why loops are very useful. So I'll add a comment now. The variable j is an int that increases with each iteration. Now, the second way we can loop through an array is kind of strange, and it might be confusing, so you don't need to remember how to use it. But there's a different type of for loop called a for each loop, and it's really the same, but it's special syntax. So for string grocery colon groceries, then curly brackets, then we can print grocery. So what is this doing? What is this colon? So string grocery is creating a string called grocery. This little colon in this situation can be thought of as in, and then groceries is our array. So this is saying for each string called grocery within our array, and then it's printing that string. So that's why it's a for each loop. For each grocery within our grocery list, print it out. So it's going to go through, this first is going to be the first item in the list, which is apple. Then on the next loop, it'll automatically become the second, then it'll become the third, and then it'll become the fourth. So that's an easier way of doing things, and you can do it with other types of arrays too, like int arrays or double arrays, but you would just need to change what this variable is, because obviously this is an array of strings, so each item within it is going to be a string. If it were an array of ints, this would need to be an int. So this syntax is really similar to how you do it in Python. If any of you know Python, you will be familiar with this and comfortable with this. In Python, you literally use the word in, so for X in my list. So that's why I like the syntax. I like Python. It makes a lot of sense to me, but if it's too confusing, all of these different types of loops, you can just remember this method right here. The variable grocery is a string that is set to the next value in groceries with each iteration. So if we run this, that second loop is going to have the exact same result. So here we have apple, bread, clementine, donut, that's from the first loop, and then we have apple, bread, clementine, donut from the second. So they do the same thing, just different ways of writing it. I'm going to add more blank print statements to clean up the terminal. And then we will move on. Alright. So this is breaking it down. I already kind of did, but it might be helpful. The first loop works just like the previous loop example. J increases each time and is used to access every value within groceries. In the first iteration, the string in groceries with an index 0 is printed, then J increases to 1 and the string with an index 1 is printed, and so on. In the second loop, we use the colon. You can think of this as meaning in. For each string in groceries, the statement within the curly brackets is executed. In the first iteration, grocery is equal to the first variable contained in groceries. This value is printed. Grocery is then set to the next variable within groceries, which is also printed. This loop does this for every string in groceries, for each string in groceries. I suppose I should add that it's a for each loop. Alright, now we're going to talk about indenting. Indentation is a lot more important than it might seem at first, but it's necessary for maintaining clean code that's easy to read. And that kind of easy to read code is important for when other people look at your code, or when you look back at old code that you wrote months ago that you don't entirely remember. So it just makes it a lot easier to look through it all and understand. It's much nicer to look at code with clean indentation and blank lines between different parts of the code with nicely named variables than it is to sort through a giant block of text that just isn't separated at all and is just spaghetti code. So yes, a lot of programming is being able to effectively read through and understand code that you wrote a while ago or that someone else wrote, your colleagues. That's why convention is really important, and indenting especially. So we'll say more about indenting as we introduce more Java. However, the general rule is easy to understand and easy to follow. When one structure is nested inside another structure, the inside structure is indented one more level. So for an example, in our programs, the main method is indented one level, and the statements inside the main method are indented 2 levels. So if we look, you'll see that it's true. You'll notice that VS Code does a lot of automatic indenting for you. So this right here is just base level, then the main method is indented 1 level, and everything in it is indented 2 levels. And it makes it very nice to read and way easier to understand than if it were all indented to the same level. Isn't that just so much grosser to look at? It's the same thing with if statements, else statements, and loops as well. Things nested within things are indented 1 more level than the header of said thing. So, in addition to that, we talked about it before, but when you have a multi-line statement, one statement that spans across multiple lines, it has a hanging indent, meaning each line beneath the first line is indented 1 more level. If you're familiar with MLA formatting of citation pages, you are very familiar with the hanging indent. But we did that, I believe, in lesson 1.java. There's one statement that spans multiple lines, so the first line of the statement is just indented normally, and then each line after it is indented 1 more level than the first one. Now, as for the size of indents, we prefer to use 2 spaces for each level of indented, as outlined in Google's Java style guide. So we used to just use the 4-space indent, which is default in VS Code, but after we decided to use Google's style guide for Java, we had to switch to using 2-space indents. So as you'll notice, so far we've been using the 4-space indents because it's the default in VS Code. So when you indent, instead of it just being one sort of indentation character like it would be in Microsoft Word or other word editors, it's actually comprised of different spaces. So right now it's 4 spaces, but as I just said, we actually want to use 2 spaces. So how can we make VS Code not give us 4 spaces every time we press tab? because I'm sure you don't want to have to type in each space every time. You just want to be able to press Tab. Well, if you go to File, then Preferences, then Settings, you can search for tab size, I believe, tab size, and then it should show up. Editor tab size, the default is 4. Just change that to 2, and you should be good. Then if you close the settings, now if I press Tab on a new file, it'll be 2 spaces. So if I do hello, and I press Tab, it's now only 2 spaces. However, in this file, it'll continue being 4 because VS Code also automatically adjusts how many spaces it makes your indents based on the size of the indents in the file. So since all of the other indents in this file are 4 spaces, VS Code automatically says, okay, in this file, indents are 4 spaces. So I'm just going to automatically make them 4 spaces for you. So if you were to import someone else's code that has different spacing than you, VS Code will adjust your automatic spacing for that file so that the formatting maintains consistency. So that's pretty nice. For now, you don't need to worry about changing the files we've already written, but going forward, we'll be making all of our files have 2 spaced indents. That is it for this lesson. Remember to go check out the review and lab video to get a refresher and reinforce everything we've learned. That will be up eventually. I hope that you learned from this and have a nice day. I hope that you come and check out Lesson 3.